In this video, I will continue talking about the magnetic force, but I will increase the level of difficulty to a significant extent. And here is the reason why. In my previous examples, I gave you Q, I told you what V is, and I told you what B is. In this example, I will tell you Q, I will tell you what V is, but the direction of B will need to be obtained. And this increases the level of difficulty in this example. So here is my charge Q. It is a positive charge, let's say a proton, and it's moving to the right with some velocity V. Now this is not part of any wire, it's just a charge and it's moving to the right. Now, as I said, in this example, I will not give you B, this will have to be obtained. But what I will tell you to get B is that you have a wire. Okay, this is the wire. And in this case, I have my electrons. Let's make the electrons move to the right, which means the electron current goes this way. This lowercase I is the electron current, and the conventional current goes the other way, of course. Now, how will I find B that I need to find the magnetic force acting on this charge? Well, here is the thought process. Every time you have a current flowing in a wire, this current, these moving charges, at the end of the day, this is what matters, that these are moving charges, they will create a magnetic field everywhere around the wire. These moving charges will create the B. Now, to find the direction of the magnetic field created by the current flowing in a straight wire, the right-hand rule that I've shown you is the following. Place your thumb of the right hand in the direction of the conventional current, and then see where your fingers are pointing. So when I do this, I see at the location of the positive charge, my fingers point straight into the page. So B at this location goes into the page. So this is the step. This is what increases the difficulty for this example. Anytime you're given a charge and something else that creates the magnetic field, it is your job, will be part of your work to show what is B. For a straight wire, the right-hand rule says place your thumb in the direction of the conventional current, and your fingers will tell you what's the direction of B. So now that I have B, I can forget about this, okay? This is no longer relevant. So I don't need to think about this anymore. Now that I got it, I'm done. So now that I have the direction of B, I'm gonna use this as before to see what's the direction of the magnetic force. As I've shown you before, I need to have my fingers pointing in the direction of V. Then I curl them in the direction of B, and my thumb shows me the direction of the cross product V cross B. My thumb was pointing up, so this is the direction of the cross product. In this case, I am dealing with a positive charge, and this means that the magnetic force also points up. So the magnetic force acting on this charge points in this direction. Now, again, where is this force coming from? Here. This wire, these moving charges create the magnetic field around the wire, and that magnetic field ends up interacting with this moving charge, giving us the magnetic force that's gonna push it that way.